comfortable talking about things that are not just on my slides regarding Windbg. So come on up and please be vocal. If I have to talk the whole time, it's really gonna suck as a class. I have here some of the downloads if you didn't grab them before in that torrent file or before the class. If you can't get to my IP address, if it's blocked, let me know. My firewall may be blocking it for you. If you can get there, let me know as well, so I can adjust or not adjust if I need to. Yes or no? Okay. Let's just do this for the minute. I think I've got everything else. Give it a shot now, see if it'll go. It should be just HTTP. Still no go. What else should I change? Firewall shouldn't be blocking this at this time. Shoot, that was my plan. I'm sorry, what? Oh, all right. I don't have anything at the time that's not on the file server. Let's go, what is it, file.saintcon? Yeah. I don't have a VM up here. Does everyone, I didn't provide a Windows VM because I kind of assumed if you were doing Windbg, you had to have a Windows VM. Does anybody not have a Windows VM? Awesome. I'm glad you guys are aware. Okay, so I guess the only thing that we need to make sure we have are those files that are in, I believe they're in the all files. Where's just the basic? They didn't. Well, that's disappointing. We need to get you those files. I don't have I have a USB. You guys trust USBs? Good answer. I'm trying to think where else I can put these that you can get to them. Okay, can you say that again? Where's it at? Okay, inside this all presentation zip, he's saying that our file is in here somewhere. Oh, right here. Yeah. And inside that is, wow, another zip file. So there, those are the things we need. They are in that presentation. Did everybody follow that? I went kind of quick. So back at files, we want the all SaintCon presentations. Inside there, we have, I want the Windows. Inside all the presentations, there's a intro to Windbg. Inside that is my slides, which you'll probably want, and then a zip file having some executables. If you open those, you can go ahead and extract them on your machine. Be very careful with exercise 3.exe. You may want to rename it for the time being. It is a rootkit, so please don't click. If you click on it before it's time to start working on that guy, it's going to make your day miserable. So just kind of set him aside and make sure you kind of quarantine him for the time being. If you don't have a cheat sheet, it'll make the class kind of a little bit easier. I'm not going to list every command Windbg does. The cheat sheet should have all the commands you'll need for the class on it, but we'll talk about that. I guess it's time to start. Everybody finding this okay, though? Everybody has the files. You will not be able to do the exercises without these files. Cool. So inside there, inside the file, before I actually start talking, let's get the downloads going. Have your Windows VM up and install inside the VM the SDK setup. That's the latest version as of like 2 weeks ago of Windbg. It should install just fine if you have an operating system newer than XP. If you have an XP operating system, that's okay. You'll just have to download Windbg from their site. Just grab the XP version. If you already have Windbg, that's fine. I noticed a lot of changes actually, though, in the new one that are kind of cool. A lot of syntax highlighting and new features that I didn't see in the older ones. So with all that, let's get started. I listed this as an intermediate class because I didn't want to have to explain x86 assembly or how a PE file is, but I want to make sure my assumptions are correct. Everybody here familiar or feel comfortable looking at assembly? Raise your hand if you feel comfortable looking at x86 assembly. This might hurt a little. What's that? You can make it, but it might hurt a little bit. Everybody who feels comfortable with a PE file formats layout, that this PE header, it has sections, each of the sections are different read-write material. Who feels comfortable with understanding the PE layout? Okay, 1 or 2. All right. If you have questions on that, don't be sheepish. Just if I brush over something, raise your hand. I'm having a hard time hearing you, but if you want to shout out and interrupt me, go right ahead. Right? And we'll make sure we cover everything, because I tend to go kind of fast when I talk, and you need to slow me down. If nobody's asking questions, then I'll probably just pick up speed and get worse and worse and worse. How many of you have used Windbg before? Okay, good, good, good. So Windbg is a dynamic analysis tool made by Microsoft themselves. And it is one of those tools that is extremely powerful, has these awesome features, but sucks in so many ways. It's going to be one of these love-hate relationships, if not already, for you with Windbg. It's got a lot of features, and it's one of the best tools. I mean, we look at the pros. First off, it's free, and it's very well embedded in Windows. So it understands a lot of Windows internal structures, like any linked list, the process lists, the SSD table in the kernel. It understands a lot of the internal structures of Windows, and it comes as a free tool for that. It will do x64 debugging, which is not something that you can find very easily for free, right? Like IDA's x64 engine, you have to pay for. It doesn't come in the free one. Remote debugging and kernel debugging. If you want to do kernel debugging, like, this is your tool. Now, we're not going to do any kernel debugging in this course. We're going to lead everything up to that, so that I was thinking maybe we'd do a follow-on course next year if we had enough interest that we could get into the kernel, but I felt like that was too much to just jump straight into. And then crash dumps, right? Error reports, Windows crashes. Windbg, you can jump those. We're going to talk about that, but you can throw those right into Windbg and see what happened, why it crashed. It's a really useful tool for exploiters as well as defenders. This class is geared toward malware analysis. But if you have questions toward how I would use this, I'm going to mention things about, exploiters use this for this. If you want to go on that tangent, raise your hand to talk and ask me, hey, what about XYZ? And we can talk about the exploitation side of Windbg as well. You can tie it in with IDA Pro, right? If you've got IDA Pro, you can say, I want to use Windbg as my debugger, and let's go with that. So learning Windbg also has benefits that you can use with the IDA Pro. So you can merge the Python capabilities of IDA Pro with the scripting capabilities of Windbg and really be quite cool. I'm not quite that talented, but I've seen some really cool scripts. The bad side is it's a command line tool. Even though it's a GUI program, it's based on command lines options. So there's a number of windows, and we'll talk about them, but they're really just kind of there. It's the heart of this thing is the command line. Its window management is horrible. It tries to dock the windows where you don't want them to. You have to remember, like, I want to save this layout, but it asks you every time, do you want to save this layout? So if you change something, you totally ruin your save settings. It's horrible in terms of GUI. It's like typical Microsoft. We're just going to put Windows in front of the user. They like Windows. And it will crash, and it will make you mad. And if you swear in this class, I understand it. I felt the same way with Windbg. You can't see this really well, but that's a typical Windbg window, right? We have here crazy amounts of data going on. I've actually docked all these in what I felt like was a semi-organized way, because it doesn't start out this way. I'm not going to try to describe that window to you. Instead, I'm just going to open Windbg myself, and we'll kind of talk through it. Let's see how well you can see that screen. That's not so bad. All right. So Windbg, right off the bat, you start with a blank screen. You may start with like this window open when you open it. Each one of these are your key places. You guys familiar with Oli? Is that the best tool you want me to compare to, or do you want me to just talk about it, Windbg in general? That fan is way loud. Sorry, guys. Okay. So the first option right there, that's your command window. This is the heart of Windbg. This is where you're going to see output going on, and once you're connected, then you can start entering your commands down here. I would recommend kind of wiggle this around until it finally docks it somewhere, and then you can add in, so you can watch variables here. We'll skip that one. Locals, that only applies if you have the source code. We'll talk about that later. The registers is a good one to have. We'll just kind of dock that to the side. Memory is a good one to have. We'll throw that over here. Come on, help me out here. No? Thank you. My screen's really small, so I'm not going to start throwing in as many as these as I would. The call stack's somewhat useful for you. Disassembly will show you, you can put in an address and it'll try to show you the hex or the disassembly for that address. Scratchpad, because we always need another notepad window, right? Like, oh, look, you can have your own notepad right inside Windbg. I don't know why they added that feature, probably just because it was easy, but we'll leave that one alone. Process threads and command browser, we're not going to talk much about. Process and threads is useful when we get towards the kernel and you're looking at all the processes and threads going on. Most of the stuff we're going to do here is in user land, which means you're going to be working with one process at a time. You can dock these and build these however you want. It's really kind of annoying. Like, once I get this, like, how do I get this back out? It just drives me nuts. Maybe I'm just not good with Windows in general. Maybe you guys will have better luck than I will. Come on. Put it right there, please. Yeah. It's annoying. When you finally get it set up how you want, then you try. Then you have to open something and then close it, and it'll ask you with this nice little. So I'm just going to open. Actually, I'm going to just attach to some random process real quick. Probably something I can kill. So we'll talk about this real quick. I guess I'm going too fast. Windbg, there's a number of ways to start your session. You can either start a new process, right, or attach to a process that's already there, or open a crash dump. I'm just going to open Notepad real quick and attach to it. And as soon as you open your first program, just give me any, there we go. It's not asking me. Oh, I've already hit the setting. Crap. So you'll get this little pop-up window if you guys are following what I was saying. Do you want to save your workspace layout? I think it's the question, something like that. And it's like yes, no, and never ask me again. What that does is how you've got your window set up, that's what it's asking you. And by default, it asks you every time you open or close a new program. So if you attach to something, it's going to say, hey, do you want to save your layout? And you want to say, no, I haven't even made my layout yet. Don't ask me to save it. So, but you never hit that don't ask me again question until you finally set up your layout how you want. Because once you set it up how you want, then you want it to leave you alone. The problem is if you set it beforehand, like it looks like I did, it never asks you the question again, and I don't know where that setting is. You'd have to look at like Stack Overflow to find out how to get Windbg to reset up the windows for you. It's another one of these, you just kind of work with the tool and put up with it. But you see, as soon as I opened Notepad here, and it started the process, and what it did is it threw in a breakpoint, but it loaded all my modules. And that's what we're seeing in my, I'm just going to make this full screen. That's what we're seeing in my command window here. It says it loaded Notepad, and it loaded all its required dependencies, and it's saying, okay, now what do you want me to do? So we can talk about, I'll talk about the commands, but I'm just going to say, oh, go ahead and run. And then that'll let Notepad run, and Windbg's here in the background. Now I can, at any time, I can pause Notepad and poke around and see what's going on inside Notepad, and I'll talk about the commands to do that. But this is just kind of the general flow of things. These are the same commands I just did. So this would be go, this is start all over, this is close the session, I'm done with Notepad, and this is pause. So, typically when you'll stop the session, it will kill the process. So you need to keep that in mind if you're trying to just attach to something, but keep it running. You may crash the process when you try to detach. Okay, so commands to know. These are your basic ones that you'll want. These ones you probably will start to commit to memory. At least most of these. If they're on the cheat sheet, but they're the ones that you're going to want to use the most, and those are your typical go in, step out, step over, run, break. Right. I'm not going to talk much about them. Watch and trace is kind of cool. What you can do is you can say, so you set a breakpoint on a function you're interested in, and you say, okay, watch and trace means run this function, but then tell me the name of every function it calls into, and then it comes back out. So if you've got a function you're interested in what it does, you say watch and trace, and it says, oh, that function called create file, and then it called write file, and then it called close file, and then it quit. And you're like, oh, well, that's nice. Now I got a kind of good summary of what this function does. It writes something to a file. So when you're looking at malware, that's really a useful feature, is the watch and trace. And the downside to that feature is it actually doesn't just say create file, write file, close file. It's actually like create file, nt query file handle, and then all the subqueries down there. And you're like, oh, that is way too much info. And so you can just say, you know what, just tell me like 3 levels deep. Don't get into the nitty gritty. Just tell me the main function calls that this function calls, and not all the little sub-calls of the children processes. So that one's kind of a cool one. This is your equivalent of run to cursor. Since we're in a command line, you don't have a cursor, so you just say run to, and you specify the address where you want it to stop at. You can set breakpoints on addresses. If you've got symbols loaded, which I'll talk about in a minute, you can set a breakpoint on a symbol. So you can say breakpoint on create file, a breakpoint on create thread. You can delete, disable the normal ones, and then there's breakpoints on memory access like your typical debuggers would have. You can say break when this memory address is accessed so I can see who's using it. And you can do wildcards. So you can say break on any time the malware calls a function in kernel 32. I don't care what it is, just tell me anytime it makes an API call. I want to kind of track what this guy's doing. And additionally, you can set a breakpoint and run a script, so it doesn't just interrupt you every time. You can say breakpoint on every time it calls a function in kernel 32, print the name of the function it's calling, and then just continue running, so that you don't have to stop and go. You can just get a listing of every call it makes from kernel 32 by doing something that simple. I'm not going to talk too much to these. They do take a little bit of a learning curve to understand how they work. The manual talks about it, but the best way to learn how these work is to use the in-line help. That's the one great thing I like about Windbg. If you do .hh and then a command, it'll open a help window and it'll show you that command, and that help is the most help. That's the most help you're going to get. But it's really a quite thorough help that they've added. I really appreciate that. Without that, I don't know how far I'd make it. But basically, if you want to see a memory, you say D and then DA, DS, whatever. Each of those A, U, B, D stands for a type. Like, show me the memory in this format. So if you want to show a string at address, you say DA space that address. If you want to see a D word at address, you would do DD space address. And then you can also specify how long of the string you want it to show. If you were going to edit the thing, instead of the D, you put an E. And then you just say, EA, this address, and here's the string I want you to write at that address. Displaying the registers, there's a register window, but if you're really comfortable with the command, the command window rather instead. I'm going to do everything from the command window just because my screen is so small. If I have all those little windows, you won't be able to read anything. So whenever I want to see a register, I'm just going to use the R command, and it'll show me all the registers, or like REAX, and it'll show me just EAX. And you can set a register by just saying EAX equals blah. And then if you want it to try to present the register in a format for you, like show me this register as a pointer, or show me this register as a float, then you can say what format you'd expect it to show it to you, and it'll display it in that way. So I'm not going to talk about those just yet. I don't want to just bore you with this is the command for this, this is the command for this. So what I want to talk about right now is what we're really, what I talked about in the slide title, right? We want to break minesweeper. That's going to be our first challenge. The rest of it we're actually talking about usable things and work. I'm assuming like malware analysis or incident response. But the first one's kind of a fun one, and it's just something to let us wrap around working in memory in Windbg. And that would be to hack Minesweeper in such a way that you will know where the bombs are. That's our goal with the first exercise. Now I'm not going to do it for you. I'm going to leave it up to you to do it. And I've got slides to kind of help walk through it. But what I'm going to do to kind of give you an idea of how this is going to work is I'm going to cheat in solitaire instead. So what I'm going to do is I'm going to open the solitaire game. So open executable. You guys can follow along. I think I give you the solitaire executable. Oh, is it on? Actually, maybe I didn't. If it's not there, then I guess you can open your own solitaire. So here's the solitaire process. I'm going to let it run. And here's my solitaire. I'm playing Vegas style, so immediately I'm already in the hole, right? I'm in the hole $52. What I'm going to do is I want a little more money than owing somebody else. So that's my goal here. Is I'm going to change my money. Now that 52, I'm going to assume I need to find that in memory. Now, there's a few ways to go about this. There's 3 different places it could be in memory, right? It could be stored on the stack as just a function variable. That's highly unlikely because I think this is something like function variables only really live for the term of that function. So I doubt that's the case for the score. It could live in a global variable, which to me would make a lot of sense because there's one score for the one player. Or it could it can live in a heap allocated variable, and that would be somewhere on the heap. So if it was a global, then that would mean it would live somewhere in the .data section of the solitaire executable, right? Because that's where all your global variables are stored in a PE file. If it's in the heap, then it's somewhere in heap memory, wherever that be. What we would do if we thought it was a global variable is we would search. First, I need to find the memory range of the data section for the solitaire executable and search it for that value. Now, it's not going to be in there -52. It's probably going to be a D word. So I'll just pull out my calculator and say 52 negative. Show me that as a hex D word. So I need to search the memory for FFFFFCC and see if I can find that anywhere in the globals. So I'm going to pause execution. First off, we're going to list what modules are running. There's solitaire. It's at this address to this address. So I can click on solitaire, and it'll show me basic information about that solitaire module. I can also say display headers on sol. Dot. All right, I'm doing something wrong. Let's pull up my help real quick, see what I did wrong. I'm going to be doing this a lot because I don't want help on solitaire. I want help on the display headers command. Oh my gosh. I need one of my own cheat sheets. Is it not the dot in front of it? This is one of the problems I have with Windbg, and you may just consider me a noob or not, but there's different formats for their commands. There's no leading dot, there's a leading dot, and there's an exclamation. The difference between the 3 is a no leading dot means it is a command that's supposed to interact with Windbg itself. A leading dot means it's a command that's supposed to interact with the debug session. And a bang in front of it means it's coming from an extension to Windbg. So it's a command that's an extension built in, added to Windbg. Now, trying to keep those straight or realizing when to use one or the other really doesn't matter much because there's no real, they try to be consistent, but to me it doesn't make sense why one will have a dot and one won't. So it's best to just kind of rely on your cheat sheet or the help menu to find it out. What I wanted to do is I wanted to display the headers for a module, and looking at my cheat sheet, I see that display headers is not a built-in command, it's an extension, so I needed to be using a bang display headers for sol. There we go. So now I can see that the data section is at virtual address 7000, so we'll take the base address for the module, which was at, so I'll scroll back up. This is the base address, add 7,000 to that, and I would search the .data section for that FFFFC pattern. Now I'm going to, in terms of time, I'm going to skip that and let you know that I've already searched there. It's not there. It's in the heap somewhere. So Windbg also has this really cool feature which says you can search the heap. And so I want to search the heap for FFFFFCC. And, oh, I'm jumping ahead here. I haven't talked about symbols. Let me fix that. I'll talk about symbols. Take a side tour real quick, because I was supposed to talk about that before we got to actual debugging. So back here, debugging symbols. If you've looked at malware at all or heard about like PDB paths, right? Like sometimes when you hear malware, they're talking about, oh, they left the PDB symbols in there and we found out that they named their project this, or it was in this folder. What that really is when you make a binary that Visual Studio says, hey, just in case you want to debug this, I'm going to put the path to your debug symbols. And so when you're running the debugger looks at that and says, oh, I got debugging information, and it's in this file over here. Let me go find that file and open it, and then that provides additional information for your debugging session. Oh my goodness, that's very tiny. Yeah, you can't see those. But so without symbols, you're just left with assembly. Now Microsoft, for each of their executables, they provide what they're calling public symbols for that executable. And what that does is it tells you the names of every function, it tells you the names of globals, and it'll provide some insight into that executable. And they provide these free, and we can configure Windbg to automatically download those for each of the Microsoft variables, or Microsoft executables. And I'll do that for Solitaire, and that'll make my Solitaire a lot more friendly because it'll tell me the name of every function and the globals that are in Solitaire. But Windbg also has another feature. If you have private symbols, then you can actually turn assembly back into the C code. Now, private symbols means you have the original source code, but the private symbols not only tell you the names of functions, but it also tells you the line of the original source file that this corresponds to. So if you've ever done debugging in Visual Studio, if you're developers, you can do that same kind of debugging from Windbg on a remote machine. So Windbg, if you have private symbols, you can go, and source, you can go all the way back to source code. That's extremely rare unless you're working on your own project. Microsoft does provide private symbols, but only for special large groups and other nations of power. So I'm assuming that's not us in here. So we're going to be stuck with public symbols. So to get the public symbols, they're all located at this server. I wouldn't just go there and download them, right? Because this is huge. This is for every executable that Microsoft has, well, not everyone, but most executables that Microsoft has put out there. That means every version of a particular DLL, there's a different symbol file for. And how many different versions of every hot patch makes a new version of a DLL. So there's lots of these out there. What we do instead is we tell Windbg, hey, store the symbols locally if you got them, but if you don't have them, then go out there and fetch it for the thing and put it in our local cache. And so you can do that with this one-line command here, assuming your C drive symbols directory exists, right? You can store them wherever, but just make sure you have a local cache and then say, and this is the path where I want you to grab them from. And as you're working on things and a module is loaded in your process, Windbg will try to go fetch that from Microsoft. Or you can set that globally with this environment variable, and all programs that read that, all being IDA and Windbg, will just go fetch this. I haven't had much success with this, and since there's only really 2 programs I ever use that use this variable, I just set it in the programs manually. Like IDA does it actually automatically, but it really only Windbg is the one that you need to set this for, so I only set this in Windbg. But the global variable exists nonetheless. So if I run that, if I copy that into my Windbg, and there's 2 ways to do this in Windbg. The one is the command that I'm going to do right there, and it should work. Or the other way is you would say set symbol path file, and you would set it right there. And once you save that, Windbg will know to pull down the images. So that should have worked, but yes. Okay, so you want to steal either this from the slides or from, do I have it anywhere else that's easily to steal? If you search on the web, like everybody talks about this, so if you can't get it from my slide, just say Windbg symbols path, and it'll give you a great, and there's an MSDN article about it. You can just pull it from there. But you run this command, or just steal this part of it and put that inside your Windbg symbols path, right? File, symbol file path, and just put that segment of it in there. So this tells it, hey, go grab locally. Now, before this works, you have to make sure you have that directory existing. So maybe the first thing to do is create the symbols folder. And then go set that in Windbg. And you'll want to do this before we do exercise 1. And that should work. So let's go back to heap search. Okay, so it's saying, hey, I found just one place that this pattern exists, and it's at this allocated memory block that is this size. It doesn't tell you the exact address where it found the memory. It just says, oh, it's in that block somewhere. You can go find it. So now I know the block that it's in. I actually really want to know the address. So I'm going to go back to my cheat sheet, or my slides that show it. I want to search memory, so that's S, for the range in a certain range in a pattern. So what I'm going to do is I'm going to say search. The range is this address. The size is 30, so that's a range. I say start here for that length, and I'm looking for, again, FFFFFCC. And it didn't like my range because I need to put an L in front of it for some reason. Let's see. Why is it not liking me? All right, looks like I need to look up the help on search. Search memory. All right, I need to tell it search memory for a D-word type pattern. I believe I have that here just so I don't have to do it again. There it is. So search for a D-word at this address. And now it says it's right here. Now, I'm not entirely convinced that this is the right thing, right? Like, what if that's in there for some other reason? So I'm just going to go play the game a little bit until I change the score. And luckily, there was an ace there. So now my score has changed. All right, my score is now 47. Negative 47, which is FFFFD1. So we're going to stop. And if all's true, then that should be the same address for D7. Right? Did I say D7? Oh, D1. Okay, cool. And that value at that address did change. So I've got a pretty good indicator that that address is what I'm looking for. So now all I need to do is I need to edit the D word at that address. And I would like lots of money. I could make that bigger actually, but I don't want to go too big. Let's just 2, 3. Cool. And we'll go back to the game and we'll see I am now rich. So that's all we're really going to do for Minesweeper. Now Minesweeper is going to be a little bit tougher, right? Because it's not just one variable you're looking for. You're looking for an array, there's a hint, array of the map. And now the map's going to have some kind of notification that this square is a bomb or it's not. And it's going to have for each square, it's going to have somehow it's going to keep track of, is there a flag on this square? Is there a number at this square? Is there a bomb at this square? So, but this is an array that we're going to be looking for in memory. So how I have this set up, if you have the slides locally, that's probably the best way to work because so the slides work like this. Let's see, we've already done that. We already talked about those, good. So this first slide is the high-level overview. If you feel like you're an ace at this kind of stuff, this is the only slide you'll need. This is more of like a challenge. This just says, here's the broad goals. You figure out how to do it. You want a little bit of help, but don't hold my hand. These questions are going to try to lead you down the thought process you're going to need to follow to answer the exercise. And then if you get stumped, then you can look at the detailed, which basically says, do these things in this order. The first one I try to walk mostly step-by-step hand-holding. There are some things that might get you caught on, and I haven't had somebody else try this slide. So if you do have any questions or anywhere along the way, please raise your hand. We'll try to spend, I don't know how long we want to spend on this. It depends on how fast you guys are. If you guys are really fast, then we'll make it all the way through everything I've got. If you're not, if you just want to take your time and go slow, that's fine. I have no determination to get to my last slide. So I'm going to just open this up to let you guys work on this first exercise. If you get it right, when you get it done, you should be able to have a very short time. Like, that's the goal, right? Minesweeper, it's like fastest time solving it. I would go to expert. Fastest time solving expert be like 10 seconds if you guys can get this, if you get through this challenge. Cool? Questions before we start? All right, rip into it. If you have, I'm going to walk around. I hope that doesn't make you uncomfortable. And if you have questions, just raise your hand or flag me down. Yeah. Okay. The minesweeper I provided is from XP. In Windows Vista, they decided to go with this cool OpenGL graphics thing, and they switched their programming style over to C++. It's still doable, but it's C++ code, and that sucks to disassemble and reverse engineer. So that's why I have the XP minesweeper there, just in case you don't want to just hurt yourself, because I don't like to do C++. So I would use minesweeper, the one I gave you. If not, if you want to use the other one and be cool and uber elite, go for it. How many of you think you found where the mines are in memory? You want a hint? Yes, no? Okay. I'm going to open it right here. Let's see, disconnect first. I'll just close this session and start a new one. All right. I would suggest checking out the symbol. Let me open a memory location. Where's my memory window? There she is. What was it? It was WinMine at let me get rid of that sucker. Come on, show me the symbol. Oh, my symbols aren't loaded. But that's the symbol I would check out. I would suggest you check out. Is this WinMine RG BLK? I think it's BLK. Yeah, it's BLK. Maybe open that in your memory window. Mine's not working because I don't have symbols, so it doesn't know where that is. But if you get symbols, you can open that in memory, and then click a mine, probably one in like the top right corner, and just see what changes in this memory location, and kind of do that a little bit to kind of figure out how this memory layout works. I'm going to load symbols just so I can see mine. Oh, whoop. Access. What's that? Oh, thank you. It doesn't seem to think I have symbols yet. All right. How many of you want more time to work on this? Cool. Okay. How many of you want us to walk through it together? Okay. How many of you just want to skip it and move on? Okay. I think the most there were for work through this together. And so I'll try to go slow, and maybe you can follow along in yours. So let me close this out and start all over again. All right, so I'm going to open Windbg. I'm going to open the executable in Windbg, WinMine. I'm going to just make sure the symbols are loaded. So list modules, full. Okay, there's my WinMine. If your symbols aren't loaded for WinMine, you can do and load symbols, this LD. I don't know what the D means. But WinMine, and that should force the symbols for that module to be loaded if they're not already loaded in your machine. At that point, let this run until it's up here. Maybe go expert. I'm going to pause it real quick. Now I think I already give you the hint where that is, but I'm going to list the symbols, or list the symbols inside WinMine. Whoops. Come on. Why am I not getting my symbols? Was it busy? No, it wasn't. WinMine. Boy, I am not having a good day. I'm sorry? Pound star? Oh yeah, that's what it is. Thank you. Yeah, X WinMine bang star. That should have worked. Yeah. You know what? I'm rather sheepish that this is not working for me. But let's just... Okay, so let's work from the hint. What I would do here is I would have seen the symbols. I would have picked the function game over, and you're not even resolving that for me. Why are you not resolving that for me? Oh, no symbols. It doesn't have the symbols for it. Please give me the symbols to WinMine. Okay, if you have them, then why can't you breakpoint on WinMine game over? Oh, Windbg, how I love you so much. Okay, yay, I was able to set a breakpoint, finally. But let's see if what I wanted to do earlier. Okay, cool. So I listed the symbols for WinMine. Out of the functions that I thought interesting, I thought game over would probably be something that looked at a bomb, right? To tell if it's a game over, it had to tell there was a bomb. So I've set a breakpoint on game over, and now I'll play until, oh, there we go. I triggered the breakpoint. So I can open a disassembly window and see where we are, and just kind of step through this to see if I can figure out, or actually what I'll do is, how did I get to game over? Well, let's look at the call stack. Well, I got to game over from step square. So step square must have been the thing that said, you stepped on a bomb. So step square is probably the guy that does it, that tells it. So I can go to that address and say, well, what's going on right where it wants us to go? And I'll back up just a little bit. Come on, back up. Or I'll just back up manually. No, I can't do that. It'll get mad. All right, fine. we'll do it this way. Set a new breakpoint inside step square, clear the breakpoint at game over. Let's try that. Clear the breakpoint at game over. Oh, nope, I cleared the wrong one. 0 indexed. Okay. And go. So let's try again. This time, okay, we hit step square. I can go look at where we are in disassembly. Okay, there we go. So step square, if you want to step through this, for the lack of time, I'm not going to just go too slow through this. But you can see it's loading this WinMine RGB BLK win block. I guess I don't know what that stands for. I don't know the coder who wrote this. And then it's looking off of that memory in here. So that's a global that it's accessing, and I want to see what's out there. So I will just go put that in my memory scope, WinMine, Bing, RG block, I think that's what it was. Thank you. That M of mine just doesn't help. All right, and there's this kind of block of memory. Now, it's kind of formatted. I mean, you can kind of change the size to format it differently. Actually, what I'm going to do, you don't need to do this, but I'm going to do this to help demonstrate some things. So this is how many squares wide? Oh, my screen's not big enough to make it that squares. I guess that many squares wide. But I could expand this window to be exactly as many squares wide as is my game. If I can cheat here a little bit. No, Windbg's not letting me cheat. Thanks. But you can kind of start to see a layout here. All right, we got 8F, 0F, 8F, 0F. Now chances are, I'm going to let this run, and I'm going to click on the top square. I'm going to let that run some more. Okay, that was a bomb. So the top square was a bomb. So let's go check out our memory. And the first square I see changed, I think, was this one right here, right? It was an 8F before, and now it's a 0F, or 8-0. So I'm willing to guess that this 8 in that flag means a bomb, and a 0 in this flag means a clear square. So to test my theory, we're going to start a new game. I'm going to pause it, and I'm going to see what's at this first square here. So pause it, go back to the memory, and now the memory shows 0F, 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 8. So if I'm correct, the first 4 are blanks, and then the fifth one, the fifth one's a bomb. So let's let this run. And 1, oh, I got to take my breakpoint out. That's getting annoying. All right. First 4 were not a bomb, and boom. Cool. We got a good idea of what's going on in the memory. But that's really annoying to try to read it like that and try to solve this puzzle. So let's make a new one. I'm going to breakpoint here and look at that memory again. So what I want to know is, I can find the flags, or I can find the bombs, but what does it look like when I put a flag on one? So, and this, I can see a bomb's in the first square. So let's see what happens when I'm going to run it some more. I'm going to put a flag on that square. Flag, pause it, and go back and look at that square. Now it's an 8E. So if we change that F to an E, that makes this a flagged square. So now everywhere there's an 8F in memory in this range, I want to change the 8F to an 8E. And that'll put flags on every one of the bombs in that memory space, right? Yeah, so he's asking why are we not like we're this first square? What are all these 10s and it doesn't start until there? I think it's some kind of border. I don't know why their memory's laid out like that, but well, so I knew that because I went kind of fast, but when I clicked on a square, that's the one that changed. That was, I clicked on like that first square and that showed that's the one that changed. You basically, it's just kind of a trial and error. You can compare the memory of, okay, I clicked on the 4th bomb over, and what I can really figure out, I don't really know, and I didn't really need to know, but how many is in a row, right? So if I click the first square on the 2nd row, then I can see what's changed and see. I can try to get the layout of this memory that way. Cool. So I need to change all of the EFs into EBs, correct? That was the goal. So what I can do, this is a little bit of a scripting to make this work, but I basically am going to do a for loop. And I have the code right here. Can you see this? This is all really hairy how I've made this, and this was kind of bonus to make it do this. I didn't expect you guys to get this far. So Windbg has scripting language in it, and I'm not going to talk about it at all in the class. But so here's basically a for. I'm going to set a temporary register, which is just a Windbg made-up register, to 0. And for as long as t is less than 240, which I think is like the size, that makes sense? That's in hex, by the way. So for each square starting at certain address, if this is equal to 8f, if that byte is equal to 8f, then I want you to edit the byte and set it to 8e. And then go. So I could just run this part right here, and that would change all of them. It should change all of them to 8es. Perfect, it did. But I don't want to stop and debug and run this. I want it a little bit cleaner. All right, well, let's make sure it worked actually first. So go back in here. Oh, look how pretty that is. I can just click to my heart's content, and if I can click really fast, I can get a really good time. There's a lot of little things I need to dodge, but I don't need to be worried about where I click. But I want this to automatically mark them for me. And the best way, like right when I click that, that's probably like new game, right? If I can find that new game function, let it initialize the memory, then I'll put a breakpoint right there, hurry and change the memory, and then say go ahead and go on with the program. And that's what I did with this script here. Is I say, okay, breakpoint on start game function. Let this function run, because I can't mark the mines until the start game functions actually set the mines, right? So this is what, so breakpoint, let this function return. Once that function returns, then clear all those memory, set the flags, and then go, let the program run. So we'll set this, let's see, breakpoint. Okay, so whenever we come to start game, it'll run this, and then since my last instructions go, the breakpoint will never just sit. It'll just go. So now when I hit new game, oh, look at that. All my mines are already set for me. Okay, kind of cool. Has no real function for us other than you can show a friend how elite you are by editing the memory. But it's not really that useful in the long run of things, but it gets you a good handle on what Windbg can do and what you can play with. So let's talk about, I've got 45 minutes, and I think that'll be enough time to get to this next section. We won't get much past that, but this is good. So crash dumps, right? We've all seen the blue screen of death, or you've all had a program crash in one way or another. When that happens, Windows typically makes a dump file for kernel if it's a blue screen, or a WIR mini dump if it's just an executable that crashes. You've seen the message, Windows error reporting, send this to Microsoft and they'll make it all better for you. You know that message, send, don't send. And it says, oh, we're just sending a little bit of information about your process or what happened. We're going to see what they send and what you can actually do with that much data. Can you still hear me? It sounds like, okay. I love the message. You can't really see this. Have you seen the new Windows 8 crash screen? That's not new now, right? We're Windows 10. The crash screen says, your PC ran into a problem and needs to reboot. We're just collecting some error info, and then we'll restart it for you. Just some error info is a lot of information they're sending. And Windows will take this data and they'll ship it back, right? You've Dr. Watson, that's where this data all goes back up to is Dr. Watson. And it wasn't until a few years ago that actually this was encrypted. It was all over HTTP post. So anybody who could see your traffic would see your crash logs going up to Dr. Watson. And the crash log contains the process, the name of the modules that are in there, the stack. It could contain the whole memory of the process, which meant passwords. Everything was going up to Microsoft and to anybody else who wanted to see it. Now, Microsoft makes huge use of these. They actually have a team that bins all these into, or they have an automated process that bins the type of crash and what process crashed and where it crashed, and it puts them into bins. And when these bins get 10 or 12, not very many, but at least 10 or 12 of the same particular bin, then they send somebody to look at it and say, is this indicative of somebody trying to exploit, or is this a crash that may be vulnerable? So they have a team that proactively is looking for exploits being developed by the Windows crash reports going back. So if you're developing exploits, make sure you turn off Windows error reporting. Don't send what you're doing to Microsoft if you want that bug to make it. So there's two types of dumps. There's kernel dumps and userland dumps. And even within kernel dumps, there's different types of dumps there. So by default, it stores one kernel dump to sysroot memory dump. And the next time you get a blue screen, it'll overwrite that. You can change that setting so it just keeps them all. And you can go look on your machine and see that's a registry setting that can be edited with group policy if you're sysadmins. You can actually make that a UNC path, assuming the machine is still somewhat functional when the crash happens, and have all your crash reports be sent to one central location. So then you can do like Microsoft does, and if you're suspecting something, you can look at your crash dumps and see, I'm seeing a whole lot of crash in this particular process, something might be up on my network. Right? That's just a technique. Microsoft has a team usually called the Wolf team. I don't know if you know about this. It's an IR team that they don't talk a lot about. Only their biggest customers that pay lots of money get to even use them. But they'll typically go to a site, and when they suspect something's been migrating around, they'll do this. They'll configure their crash dumps all to come to a central location, and they'll quickly run some kind of analytic on the crash dumps to see if there's something going on there that they've never seen before. So they're extremely useful, but there's three types. There's a complete core dump, which dumps all physical memory, and that's huge, right? Like you've got 16 gigabytes of RAM, it's a 16 gigabyte file. That one is not the default, but it's huge. Keep in mind that if you've got a paging going on, which you typically do, the page file is not included in the dump. Only the memory that's in physical memory is included in the dump. So if it's been cached out, it doesn't make it. The normal kernel memory dump, which just dumps all the kernel memory when a crash happens. And then there's the small dump, which is sometimes called a mini dump, which contains just kind of where the crash happened, the call stack, and maybe some other related information to help you diagnose the crash, but it's not going to give you all the memory. User dump, again, there's a lot of different types for that. There's the registry path to where the local dumps are stored, but typical is this path. You can go check there now and see how many of my program crashes do I have, right? Like if you've ever had a program crash, it's usually going to leave a dump here unless the program or the system is opted out of leaving error messages. If you're an exploit writer, there is a function called to say, I want to opt out of WIR for this process that I'm running in right now. So you can go call, it's like WIR disable. And that way, if you crash, your module or your exploit code is not going to be caught in this dump and later harvestable by somebody else. Reversely, if you're a malware analyst, you can look at a dump and pull from that dump possibly the module that was running. And that's the next exercise we'll be doing. Is I will give you a crash dump, and you can see what malicious code was running there and extract from it the malicious module. Now, there's lots of types for that. There's the full dump, the mini dump. A lot the same. Full dump gives you the whole memory space of the process. Mini dump just kind of gives you some of the things. The name mini dump can be misleading because there's a lot of options for mini dump. Some of those options will actually make mini dump bigger than a full dump. So there's kind of a misnomer that mini dumps are always smaller. They're not. So I think volatility can look at crash dumps. I learned that just the other day from Jeff. And I don't know if Oli can. I don't think Oli has any functionality for it. I don't know if any other tools. Does Redline do crash dumps? Anybody know? So, but Windbg, not only will it give you, it'll open the crash dump and show you what's going on. You can do, it's got this module called Analyze. It'll tell you why it thinks it crashed. So not only does you get the error code, but it'll say, hey, this program crashed. I think it was this reason in this function. So it'll kind of point to the call stack and say, this is what went wrong right here, which is kind of helpful if you're an exploit writer, right? If you're fuzzing something, you want to turn this on, and then just collect your crash dumps and run kind of a scripted Windbg to see, am I getting crashes that it thinks might be actually exploitable? And then to even improve that, there is a module called exploitable that you can install into Windbg to help you determine if the crash you made is an exploitable crash or not. That helps a lot in fuzzing, but again, that's not for this type of course. So I'm gonna do a crash dump just to give you an idea real quick what goes on. Let me open one real quick. Let's see. Open a crash dump. I've got one saved over here that looked particularly interesting. All right, loaded the module. I'm going to say analyze verbose. Wow, that was very fast. Faster than I expected. So we'll go back up and say the exception to first off, the process is Internet Explorer. The faulting module where the crash happened was inside the MS-HTML, which is the parsing DLL for Internet Explorer. So it was parsing a web page, most likely, where it crashed. And the type of crash, the analyst, let's see, where is it? Should be down here. We can get a lot of information about the machine or whatnot in here, but for us, we don't really care too much. Why is it not showing me it, or did I miss it? Exploit analysis, blah, blah, blah. My symbols aren't working. Oh, my symbols aren't working. Ah, Windbg. Why are you not saving my symbol setting? I think, Jeff, you were having that same problem. Oh, nope. Please save. Please. Okay, let's try this analyze again. I was wondering why that was so quick. It was so quick because it didn't have any symbols. It'll take it a minute. Okay, there. So this is the bucket for Microsoft's reasoning, which pretty much tells us what's going on here. Status guard page violation. Do you know anybody know what that is? Off the top of your head? So when you allocate something in a heap, a guard page is something that's written right before and right after the heap. So that if there's an overflow attack on the heap, it writes onto the guard page. And then the guard page is like, whoa, buddy, this is my territory. We're calling it right here. You're doing something you're not supposed to. And so that's what hit. Now that's not enabled by most things, and you'll see the reason that hit. If I list the modules that's running or loaded into Internet Explorer here, this guy, Emmett, our buddy, Emmett was loaded on this Internet Explorer. This actual crash was the Flash hacking team exploit thrown at this Internet Explorer. Emmett was running. Emmett caught it and said, "Well, you're doing something you're not supposed to. I'm crashing the process." And that's this crash dump. Now, how I got this actually was somebody uploaded this crash dump to VirusTotal, and I was just doing a search and found this crash dump on VirusTotal. There's a lot more I can do. So it gives you the layout of everything as at the time of the crash. So I could say, oh, show me the call stack. The call stack for this one's not really deep because the call stack's already been smashed. But the crash dump you're going to have, the call stack will still be legitimate, so you can see where the program was when it crashed and what else is going on. So I can also see, I can list loaded modules at the time of the crash. There's also another function that I haven't talked about yet. I think I kind of slipped over that slide. But Windbg also has a scan IMG function. I think scan IMG. Pretty sure that's what, or IMG scan. Man, I'm dyslexic. What this will do, so loaded LM lists modules that have been legitimately loaded into the process. Scan IMG will look through the memory space for that MZ header and say, well, hey, I think I found a PE file loaded in memory here that's not in the loaded modules list, right? So anything that does DLL injection into a process from memory, you can find doing some trick like this. And so it's going to find all the modules. Now, all these ones are the ones that are loaded legitimately. But you can look through this list and see if you can find any here that don't match up the other list. And that's about the point. Oh, one other thing. Windbg also has a feature to extract from memory a DLL and drop it back to disk. However, the one that's built into the system has some weird requirements that the process has to be a .NET process and has to have these things loaded. And that really just ticked me off. So what I did is I wrote my own extension to Windbg that I've shared with you guys. And to use it, what you need to do is this dumper folder. There's a Win32 version, and there's a x64 version, depending on which version of Windbg you're using. But I'm using the Win32, so I am going to copy that and place it inside. If you go C drive, program files, I believe it changes between versions, but mine's under Windows Kits. If you've got a newer Windbg, you want to find your debuggers folder. I'm using x86, like I said, and there's a Win extension folder. You could just search for that folder and paste this guy in there, right? I'm going to try to hurry and do this next step. I'm going to run Meterpreter. I'm going to exploit one of my box, run Meterpreter on it, and then I'm going to use Windbg, attach to that process, and pull Meterpreter out of memory. Just kind of give you an idea. Hopefully everything goes well, right? This is a demo that I'm going to cross my fingers on because I'm doing an exploit in front of people. So, see if this all works. We'll start up MSF console. I'm going to close this out, close that out. I don't need that. Oh, your copy's done. I can give you your file. And I don't need that. Sorry, it's a little late now, but all right. See if MSF console's up now. I should have started that. Oh, perfect. Let's see. You guys familiar with Metasploit, or should I talk about it as I'm going? You guys good? I'll talk slightly. All right. I am going to use the Hacking Team Flash exploit that just came out. If I can see that there somewhere. That's not. Where'd it go? Exploit Adobe. Gotta be right there. Oh, there it is. Hacking Team exploit use after free. And I just did the wrong command. Where'd it go? Oh, buddy. What is going on? Windows, Interpreter, reverse, HTTPS. Shouldn't be that hard. Thank you. What's my IP? 168, 66, 150. All right, I just got to get my victim. Click on that link, which is easy, since my victim will do whatever I tell him to do. Excuse me. High rollers, no whammy. Aha! We got a session. Life's on my side today. Cool. So yeah, I'm running on that guy. And at this point, we're going to jump over to the machine, and we're going to attach to that process. Internet Explorer, the child. Okay, cool. So now we're in this guy, and if I list modules, I can see what's running, but I don't see Meterpreter at all in this list. I'm not going to see it, because Meterpreter is injected into the process memory using their little reverse injection technique. But I'm going to go look for that guy. Here's all the images it found and locations. Those all look good. Those all, oh, a little faster. Met server, there you are. Now it found a few possible candidates. It found 4 here, but a lot of them, I'm going to try the one with the largest size, because the others are probably just portions or part of it. When it was loaded, it found it in memory. So we'll try that, and I'm just going to make sure it looks good by, let's see, oh, that's an extension command. Display headers. Okay, cool. I got the relocation section, data section. It looks good. So to use if you put my module in the right spot, all you have to say is first load dump, which will bring in my extension. And then you can do so whenever you load in the extension, you can do the name extension bang help. Where is it? Bang. Thought I had that. Yeah. It is bang.help, and it'll show you this extension provides these functions. Mine only brings one function called dump module. You give it an address and a file, and I will dump that module at that address to that file. So simple enough. Dump module at address that C drive temp net serve DLL. Boom, created that file. And I've got my metserv. I can go do whatever static analysis on that. I've now got an artifact from this attack. I can load a device total. I can show, if you're an IR team, you can show the team, this is what I found. This attack, this thing also works for crash dumps, which is what your next exercise is. I think we'll use that for the rest of the time, unless you guys are going really fast. So exercise 2, you're going to play with that crash dump that I gave you. Where is exercise 2? Yeah, you got a crash dump, and you need to find out what the malicious action was that was going on at the time of the crash dump. What process was the crash in, and extract the tool if you can. Once you extract it, I'm not telling you what the tool is, but you can load a virus total or use some kind of whatever you use to look at module static analysis, and you should be able to determine what it is right away. Just to search on some of the strings. If you have any questions, feel free to, I'll again wander around. The bonus, what caused it to crash? That one might be a little trickier because it's not well, I altered the module so that it would crash. That's kind of handled the bonus, but that's neither here nor there. You can just kind of skip that for the time being. Just see if you can pull from memory what happened, or tell for what happened from that crash file. You know what file I'm talking about? It should be right. This guy, this workum whatever mini dump file. So open that in Windbg and tell me what happened. I gotta find out why mine's not saving my workspace data. Oh, you know what? Maybe I should just force it. How we doing? You guys, one more time? Okay. And do you guys like? Do you like walking through this? Maybe we'll give some more time and then walk through this together. Did you guys like that last time, or just skip it? Okay. Okay. Maybe like 5 more minutes, and we'll walk through it, and then I'll just. Well, I guess I might, if I have time left, I might try to touch on the last material in case you guys want to play with the third exercise at home. Oh, about ready to walk through this together? Yeah? Okay, cool. So I already loaded the dump into my memory space. And that's not what I want to show you. This side. Okay. And what I did was I forced all the symbols to load by doing an LD star. So that loaded symbols for every module in there if it could. Then when I listed modules, I could see, and I did a list modules with a -F, I could see all the ones that has symbols for it. If it has symbols for it, that's a good indicator that it's by Microsoft. If it doesn't have symbols for it, it means it's probably a third-party product. So I can just go through this list rather quickly and look for things that don't have symbols. Oh, no symbols. this guy, and that guy. Now this one, it says it doesn't have symbols. Oh wait, sorry, I'll skip that. So there's two modules of particular interest. What I'm going to do also is I'm going to do a look at the call stack at the time of the crash. And we can see that the last call before dropping in the NTDLL was from this guy right here. So that gives me a good idea that, one, this guy is probably the one I'm interested in, right? It's the one where the crash started from before it went. Did Analyze tell you that's where it was? Or maybe Analyze told you it was a... Got to spell it, right? Yeah, Analyze is like, I'm pretty sure this guy's our faulting module. So I think I had you list strings, but that's not technically necessary. So all I really wanted to do is we're going to load my dump module and dump this guy to disk and figure out what it is. Sakura, I think I could probably just put it in like this. Did anybody else get that error? All right, that might be, let's see, dump headers at Sakura. Can't read file header. It might be because that's not all the way there. I thought it was. I apologize if that's the case. Well, Lauren, that's a fail on my part. It looks like I give you a memory dump that's a small memory dump that did not contain all the address space. So I apologize off the top of I thought I double checked this too. So yeah, you have a memory dump here that does not contain the full address space. It just contains the call stack, the function parameters, and registry or registers. So we can see what caused the crash, but we don't have the module to be able to extract it, and that was my bad. I should have made the dump a little bigger. But anybody recognize that file name? That is actually the workhorse behind Mimikatz. You know, anybody knows what process we were in? Should show us back at the yeah, it should show us back at the analysis. We were in LSAS. LSAS has the passwords, and that's what Mimikatz was after at this time. That's what this program does. Is it was trying to rob the passwords out of memory, but I messed up one of the instructions on purpose, so that the program would crash inside its get passwords routine. Had I done it right, and you could have pulled the module down, if you would have loaded it at VirusTotal would have been right away. This is bad. We know it's bad. This is Mimikatz. Even with my modification, it would have had a new hash. Most of the vendors would have picked this guy up right away. So sorry for that one. I felt bad that I didn't get that one right. All right, so just real quick, and then we'll get out of here. I'll let you go. There's not much to these last few slides. I just wanted to touch on, I wouldn't do this justice if I wouldn't talk about remote debugging. Windbg has the ability to remote debug both in user space and kernel space. In kernel space, it's absolutely necessary. I mean, not absolutely, but you don't do kernel debugging from the machine you're on. As soon as you pause the kernel, the machine is done, right? It's stopped. So you have to remote debug a kernel. And remote debugging the kernel is a little bit of a process. You have to basically change it in the boot sector to tell the machine, expect a debugger to attach to you during boot. And then you can configure it. Most commonly, it's a COM port. So if you're working in a VM, you make sure the VM has a COM port. Tell the debugger, hey, expect a debugger on this COM port. And then outside the VM, I work on Mac, so I have a separate VM where I run my Windbg that attaches to the first VM that I'm debugging in kernel mode. And then from there, the machine will stop as soon as you attach before it's even done booting. You can play with things, and you can jump into any process or look around the kernel. I'm not going to talk about kernel memory at all, and we're out of time anyways. Remote debugging in userland is a lot easier to set up, and it's kind of clunky though. You basically run Windbg on the machine and then say, hey, expect Windbg to attach to you on this port. So you can just run this command on the host, and then on the client one, you just say, hey, attach to that port on that server. And then you can just run Windbg from another machine. Why would you want to do this? A lot of malware will try and inject itself into Explorer or LSASS or one of these key processes, so that if you try to pause and attach a debugger to that process, if you pause Explorer process, then you can't browse your files. Anytime you would get in this like deadlock, right? If you pause Explorer and then try to browse a file or search the directory in any sort of way inside Windbg, it's going to send a message to the Explorer process and say, hey, show me the directory. But Explorer's paused, so then Debugger's now paused, and then you're in this endless loop where you can't unpause yourself. So that's why you have to do remote debugging when you're doing one of those core processes. A lot of malware authors know this, and so they try to inject into Explorer for that purpose, just to try to get the novice the analysts off their back. And that's really all I wanted to talk about. The last exercise is that exercise 3.exe. It is a rootkit that I wrote. It's just a userland rootkit, nothing that's fancy. It does not do anything malicious. If you reboot the machine, it'll go away. But it's there. It has a few anti-analysis, dynamic debugging tricks built into it. And it does try to hide some files. Once you run it, try to make a file with a tilde in the file name, and that'll just disappear from your view. And so play with it. You can just get an idea of basic tricks. It's a scarecrow, right? It's a stick figure. It's not a really mean userland rootkit, but it'll expose you to userland rootkit principles, how they work, they hook functions, and what they do. And so if you want to play with that after the fact, feel free. You can email me or text message or send me a Facebook message. Not Facebook. I don't Facebook. Twitter. Twitter's the word I'm trying to say. Send me a message to my Twitter handle, and I'd be more than willing to answer any questions you have about this or any other Windbg questions. But with that, any last questions before we leave? Cool. Thank you very much. I apologize. I hope it was worth it for you guys. I hope you learned something useful. And I'd love to see more people get into Windbg because it's not going to go anywhere. It's free, and it's a really powerful tool. I think it's heavily underutilized just because it scares off a lot of people, but it's really worth getting into. So thank you.